All right, guys. Sorry I couldn't be there today. We're going to learn something new. Um, we're going to start off talking about division. Now, I guess before we get into division, we need to talk about something that goes on in Python. So we've got our two number types, right? We've got floats, which are like decimal numbers. We've got ints that are whole numbers. Well, when you do the four basic operations, addition, subtraction, multiplication, division, if there's a float involved, your answer will be a float. So, for example, here we've got two floats divided gives us a float. A float and an int divided gives us a float. An int and a float gives us a float. So if there's a float involved in one of those four operations, we're going to get a float for our answer. For integers, though, if you do an integer plus an integer, it's going to spit out integer data. Same thing with subtraction, same thing with multiplication, and the same thing with division, which is a little weird to wrap your head around at first, because when we do 5 divided by 2, we should get 2.5. But it's going to spit out an int. It only spits out the integer part. It cuts off the decimal. Let's absorb that again. 5 divided by 2 should be 2.5, but since this is an int divided by an int, it only gives us the int part, the integer part, the whole number. So for example, 25 divided by 3, usually that's 8 and some change, 8 1/3. It'd be like 8.33333. But since it's integer division, it just gives us the 8. 1 divided by 2 usually would give us 0.5, but since this is integer division, instead of 0.5, it just gives us this 0. Okay? Of course, 20 divided by 2 works the way we would think it would, because 20 divided by 2 is just 10, so that's what it gives us. Again, 7 divided by 8, usually there would just it would just be a long decimal there, 0 point, and then a bunch of decimals there. But since it's integer, it will only give us the 0. 13 divided by 5, 5 only goes in 2 times, and then it just gets rid of all the leftovers. Okay? Now let's look at this new operation. It's called modulus, or sometimes just mod for short. It uses this percent sign. Okay, so if you look on your keyboard, right above the 5. So what this does is, imagine we were doing division and we got this remainder. Well, what this does is it says, if we divide 25 divided by 3, what would be the remainder? So let's, I'm going to make this a little bigger. We're going to take a look. We're going to do some old school long division. 25 divided by 3. Well, what multiplies by 3, or how many times does 3 go into 25? Well, that's 8 times. Okay? Well, that only gets us 24, so what's left over? We have a remainder of 1. Well, here's how this ties into what we're doing right now. If we do 25 divided by 3, if we do integer division, no floats, it's only going to spit out 8. It's going to spit out this guy right here. If we do modulus, modulus is asking for the remainder. So it's 25 mod 3. 25 divided by 3, the remainder would be this 1 right here. Okay? So when you do like long division like this number is what you would get if you did integer division in Python. This is what you would get if you did your modulus. Okay? Let's look at another modulus example. So 1 divided by 2 doesn't divide in at all. So all of this is going to wind up being our remainder. Okay? 20 divided by 2 is 10. There's no remainder. So when we do modulus, the remainder is 0. There's no leftovers. Again, 7 divided by 8, it doesn't divide in, 7 can't go into 8 at all, so it's all remainder. 13 goes into 5 twice, so there's 2 5s, that's 10. So 13 minus 10 is 3. All right. Modulus kind of works like a clock does, okay? So what I've done is I've made a clock, but instead of it going 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, this clock goes from 0 to 5. So think about how a clock works here. Normally, we'd go 1, 2, 3, 4, 5, but instead of 6, we're going to go back to 0. 7, 8, 9, 10, 11, and then at 12, we hit 0 again. So every multiple of 6, or whatever your mod is, you're back to 0. So look at this example right here. 0 mod 6 is 0, 1, 2, 3, 4, 5. But when we hit 6, we're back to 0. We hit, and then it's 1, 2, 3, 4, 5. And then when we hit another multiple of 6, we're back to 0. And the same thing would happen if this was mod 4. We would do 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. It just goes around like a clock. And then when it hits that number that we're dividing by, it goes back to 0. The last thing I want to show you is a little trick that you can use with integer division and modulus. Okay, so when you divide by 10, normally all that does is it moves the decimal over one time. So the decimal, instead of being here, would be here. But remember, integer division, we get rid of the decimal. So look what happens with this number. We've got this big, long, nasty number, but all that happens when we divide by 10 is it gets rid of the 6. Same thing here. We've got this big, long, nasty number, but when we divide by 10, instead of moving the decimal place over, it just gets rid of the last number. So that's going to happen every time we divide by 10. Well, if we divide by 10 like that, what's going to be the leftover? What's going to be the remainder when we do modulus? Well, it's that last number. So when we do divided by 10, we get rid of the last number. When we do mod 10, it gives us the last number. And the same thing happens when we do 100, except for instead of it being the first number, it's the first 2 numbers. If we divide by 100, it gets rid of the 2 numbers. If we do mod 100, it gives us the last 2 numbers. All right, guys. I hope you got most of that. If you have some questions, feel free to hit me up when you get back. When I get back. I'll see you later.